Hi, welcome to Algebra 2 Common Core. Today we're going to continue working with the sine and cosine functions. So when we have a unit circle and we draw an angle theta in standard position, remember that the terminal ray is going to pass through the point x comma y on our unit circle. Now in the last lesson we learned that the sine of the angle will always be equal to the y coordinate of that point, and the cosine of the angle will always be equal to the x coordinate of that point. So we can use that idea to then combine our unit circle with evaluating trig functions. So if I'm given the function f of x is equal to 6 sine of x, I want to find the value of f of 60 degrees. So let's first of all write out what that function is. F of 60 degrees is really the same as 6 times the sine of 60 degrees. Now very often what's going to happen for this type of problem is that I need an exact value answer, so I'm not going to be able to plug this into my calculator because my calculator is going to give me a decimal approximation. So I need to first evaluate the sine of 60. I always start by drawing this on my unit circle. 60 degrees I know is in quadrant number 1, so we're going to draw the terminal side where this is my initial side. So making the triangle, I drop down from that ordered pair to my x-axis, and I know that this angle inside here at the vertex, at the origin, is 60 degrees. So I need to know what are the coordinates of this ordered pair. So here's 1 as my hypotenuse. Across from the 60-degree angle, I know that that's radical 3 over 2. You'll see that we really have to be familiar with that 30, 60, 90 right triangle. And that tells me that the side, the one across from the 30-degree angle, must be 1/2. So the ordered pair that I have right here, and I can get rid of the extra there and just talk about this ordered pair right there, is going to be the coordinates 1/2 comma radical 3 over 2. I'm in the first quadrant, so both of those values are positive. Now if I want the sine of 60, we know that the sine is always going to be the y coordinate of that point. So the sine of 60 is radical 3 over 2. Now for this one, our function says take the function value at 60, which tells us to multiply 6 times the value for the sine of 60. So 6 times radical 3 over 2. That's giving me 6 radical 3 over 2, and I can divide 6 divided by 2 and give me 3 radical 3. So looking up in my answers, I see that that is choice number 2. Let's try example number 2, where this time I'm talking about g of 330 degrees. So that tells me that I want to draw my triangle on my unit circle at 330 degrees. So again, make your unit circle. 330 degrees means I'm most of the way around the circle. So going all the way around like this is 330 degrees. But I'm looking for the triangle that touches the x-axis. So I'm going to go here, here, and here. I need to know what this ordered pair is right there. The angle inside the circle, inside the triangle, is going to be 30 degrees, because that's the reference angle. That's how much I'd have to go from 330 degrees to get back to the x-axis. So across from the 30-degree angle, I know that that side is going to be 1/2. Across from the 60-degree angle, that side is going to be radical 3 over 2, and the hypotenuse is, of course, 1. So the ordered pair would be, I'm going to the right radical 3 over 2, I'm going down 1/2, so that tells me my y coordinate is negative. So identifying these values, I know that the cosine of 330 degrees is equal to the x coordinate, radical 3 over 2, and the sine of 330 degrees would be the y coordinate, so that's negative 1/2. And And again, I can check with what I learned in the last couple lessons. I know that in the fourth quadrant, cosine should be a positive value and sine should be a negative value. Let's substitute in my 330, so I'm going to say 4 times the cosine of 330 minus 2 times the sine of 330. So let's use these values that we just found from our ordered pair on our unit circle. So we're going to say g of 330 is going to be 4 times the cosine radical 3 over 2 minus 2 times the sine negative 1/2. Now when we evaluate that, I can see that the 4 and the 2 can be divided, so that gives me 2 radical 3. And then negative 2 times negative 1/2 is positive 1. So I'm looking for choice number 3, 2 radical 3 plus 1. Now for the next one, it says, which of the following is not equal to 1? Now I hope you recognize that to get an answer of 1 for a sine or cosine, that means that I must be at one of my quadrantal angles. So I'm going to draw my unit circle and identify the coordinates at the quadrantal angles. So here, this point at 0 degrees would be 1, 0, and I'm going to mark it 0 degrees. At 90 degrees, the ordered pair, I've gone over 0 and up 1. At 180 degrees, I've gone to the left 1 and up 0. At 270 degrees, I've gone 0 and then down 1, and then 0 would give me the same answers as 360 degrees. So where am I going to get answers of 1? Let's check each of these solutions. Cosine of 0, so I'm looking over here at 0 degrees. Cosine I know to be the x-coordinate, so therefore the x-coordinate is equal to 1. 360 degrees is equivalent, so that x-coordinate would also be equal to 1. Sine of 90 degrees, here's my 90 degrees. Remember that sine is really the y-coordinate, so that y-coordinate is also 1. But when I check my last option, sine of 270, I'm looking for the y-coordinate of 270 degrees, so the y-coordinate there is negative 1. So that's the only one that does not equal 1. So choice 4 is the answer there. Now in example number 4, it says, for an angle alpha, whose terminal ray lies in the third quadrant, it is known that the cosine of alpha is equal to negative 0.96. Now again, that makes sense. In the third quadrant, we know that the cosine, which is the x-coordinate, has to be negative because I'm moving to the left, so any x-coordinate would have to be negative there. We want the value for sine of alpha. Now, just to eliminate some answers here, in quadrant number 3, we know from our picture of our unit circle, first of all, sine is equal to the y-coordinate. So if sine is the y-coordinate for any angle in the third quadrant, my y-coordinate has to be negative because it's a point that's going down from the x-axis. So the sine has to be a negative answer. So I am going to eliminate the answers that are positive because they can't even possibly be true. Now let's go ahead and narrow it down between the other two answers. When I'm given cosine and I want to find sine, we've been practicing with this where we use our Pythagorean identity. So we're going to say cosine of alpha squared plus sine of alpha squared. And again, the angle could be called anything. As long as those two angles match, we know for sure that cosine squared plus sine squared equals 1. So I'm going to put negative 0.96 in for cosine of theta, or alpha, plus sine of alpha squared equals 1. So when I do this calculation, I'm getting that sine of alpha squared is equal to 1 minus negative 0.96 squared. So sine of alpha squared, when I do that calculation on my calculator, it gives me 0.0784. Now normally we would take the square root of both sides, and we would take the positive and negative square root on the right side. We know that our answer has to turn out negative because we talked before about how it has to be in quadrant number 3. So I'm going to take the negative square root on my calculator, and I got negative 0.28. So check your work with mine on your calculator. Now for the next example, we also need our calculator. So if you need to, pause the video and go grab your calculator because you're going to need it for this problem. So for example number 5, it says there's a special relationship that exists between trig values of any angle and the trig value of its reference angle. So we would like to investigate what might be that relationship. So for each of the following, we're given an angle, we're given its reference angle, and using our calculator, please be sure that you've set your calculator into degree mode. So hit the mode key and make sure it's on degree right now. We want to find the sine and the cosine of both the angle and the reference angle. So for each problem, I'm actually doing 4 different answers. So watch how I set this up. I want to do the sine of 110 degrees. I want to do the sine of 70 degrees. I want to do the cosine of 110 degrees, and I want to do the cosine of 70 degrees. So using my calculator, I'm going to type each of these in, and I got that the sine of 110 degrees is 0.94. The sine of 70 degrees is also 0.94. Very interesting. The cosine of 110 degrees, that's negative 0.34. And the cosine of 70 degrees is positive 0.34. Now what I'd like you to do is set this up for each of the next 2 problems, B and C, where we're finding sine and cosine of the angle and its reference, and round each answer to the nearest hundredth. Come back and check your answer with mine, and we'll talk about the answers. Now first of all, compare your answers with mine. Now our first angle that we were talking about, the angle is 110 degrees. We found the reference angle by figuring out how far 110 degrees was from the closest x-axis angle. So how far away is it from 180 degrees? Now you'll notice that 110 degrees is in quadrant number 2. And in quadrant number 2, the sine answer for the angle is equal to the sine answer for its reference. But the cosine answer was negative, while the reference angle answer was positive. Let's go to the next example. 235, that's in quadrant number 3. So when we're in quadrant number 3, we see that the sine answer is negative, while its reference is positive. Cosine, same exact thing. The angle in the third quadrant had a negative answer, while the reference was positive. And let's go to the last example where we're talking about an angle in quadrant number 4, 282 degrees. Sine answer in the fourth quadrant turned out negative, but its reference angle was the same exact answer but positive. In quadrant number 4, the cosine answer was exactly the same as its reference answer. So we're going to make a little conclusion box. So first of all, our conclusion is the answers match exactly except for the signs. So a trig function and the value of the trig function at the reference angle are the same number. So the absolute value of each trig function in any quadrant is always equal to the trig value of its reference angle. Now let's take a look at the positives and negatives. Did you notice that in quadrant number 1, the reference angles always end up in quadrant number 1? We ended up with the sine of any angle in quadrant 1 and the cosine of any angle in quadrant 1 always being positive. Now, of course, that makes sense because if I'm in quadrant number 1, my x-coordinate and my y-coordinate both have to be positive. In quadrant number 2, we found out that the sine was positive, but the cosine was negative. And again, if you think about that, it makes sense because sine represents the y-coordinate. I'm going up in quadrant 2, so that'll be positive. Cosine is the x-coordinate. I'm going to the left, so that tells me that I must have a negative answer for cosine. In the third quadrant, I know that both sine and cosine turn out to be negative values. And again, that makes sense because in the third quadrant, the x and the y coordinates would both be negative. In quadrant number 4, the sine is negative while the cosine is positive. And again, that makes sense according to our ordered pair. So now let's look at example number 6. We're going to try out these properties where we know the answers for the reference angle. So this time what we're going to say is that the reference angle for each of these angles given in this example is going to be 30 degrees. So in the first quadrant, the cosine of 30 is radical 3 over 2. The sine of 30 is 1/2. When I look at part A, cosine of 150 degrees is an angle in the second quadrant. 150 degrees does have a reference angle of 30 because it's going to go from 150 degrees to the closest x-axis, which is 180. I have to go 30 degrees, so the reference angle is 30. But in quadrant number 2, I see that cosine is negative. So this answer should turn out to be negative radical 3 over 2. So I'm taking the answer for the cosine of 30, but I'm negating it because now I'm in quadrant number 2. Sine of 150, same exact angle, still in quadrant number 2. Sine I know to be positive, so I'm going to keep the answer for sine of 30, and it's also going to be positive because sine in the second quadrant is positive. Let's go to 210 degrees. That's in quadrant number 3. So in quadrant number 3, I know that I have to get back to 180 degrees, so my reference angle is still 30. So my answer for cosine of 210 will also have a radical 3 over 2, but in quadrant number 3, I know that cosine is negative. Sine in quadrant number 3 is also negative, so I'm going to take the negative of the sine answer, negative 1/2. The last example that we're looking at is 330 degrees. That's in quadrant number 4. It still has a reference angle of 330 degrees because I'm 30 degrees away from 360. So in quadrant number 4, cosine is positive, so I'm going to take the positive answer for the cosine of 30. In quadrant number 4, for the last part here, sine is negative, so I'm going to have the negative answer for the sine of its reference angle. So take a look at those and see how those pieces all fit together when we talk about the reference angle, the ordered pair on the unit circle, and also whether sine or cosine is positive or negative in each quadrant. So we need all those 3 pieces to fit together to be able to get these exact value answers for sine and cosine. So we've been doing quite a bit of work with our reference angles, and in all cases so far, I've just been referring to how far away the terminal side of the angle is from the x-axis. Now the x-axis is either represented by 0 degrees, 180 degrees, or 360 degrees. So it's pretty easy to come up with a formula for each of these reference angles. It's not necessary for you to memorize these formulas if you're having no trouble whatsoever finding these reference angles. in quadrant number 1, if my given angle is in quadrant 1, then the reference angle is just equal to itself. So remember that a reference angle has to be an angle that is less than 90 degrees. And all angles in the first quadrant are less than 90 degrees. So the reference angle is just the given angle if the angle falls in quadrant 1. If the angle falls in quadrant number 2, then we're going to find the reference angle by saying, let's take 180 degrees and subtract that second quadrant angle. And that'll tell us how big the reference angle is. In quadrant number 3, we're still going to be measuring from that 180 degree mark, but in quadrant 3 the angles are all bigger than 180 degrees. So we're going to take the given angle and we're going to subtract 180 degrees to get the reference angle. And in quadrant number 4, this time instead of measuring from the 180 degree side, we're going to measure from the 360 degree side. Since our angle is in quadrant 4, it's going to be an angle that's between 270 and 360 degrees. So to figure out how far away it is from the x-axis, we're going to take 360 degrees and subtract the given angle, as long as the angle is in the 4th quadrant. So let's look at example number 7, where we're going to put all of these pieces together. If I want to find the sine of pi over 2, my first step is to convert my angle, pi over 2, over to degrees. So I'm going to multiply by 180 degrees over pi radians. You'll notice that the pi radians cancel. 2 goes into 180 90 times, so this is the same as 90 degrees. So I want to find the sine of 90 degrees. Now the second thing that I want to think about is what quadrant is my angle in. This answer, this 90 degrees, happens to be a quadrantal angle, so it's not in any one quadrant. So in this case, to evaluate it, I am going to use my unit circle, and I'm going to evaluate, let's make my unit circle, let's go to 90 degrees, and find the ordered pair, 0, 1. Remember that the sine of 90 degrees will always be equal to the y-coordinate, so in this case, that answer is equal to 1. So that's how I go about finding an answer without using my calculator. Most of the time I'm not going to be able to use the calculator because they will be irrational answers. This one wasn't irrational, so you could always check it on your calculator. Let's go to B. Step number 1, if it's an angle given in radians, I want to convert it over to degrees. So let's multiply by 180 degrees over pi radians. Cross cancel the pi's, and I see that the angle that I'm talking about in terms of degrees is 60 degrees. So I want to say, what quadrant is that in? That's going to be in quadrant number 1. So I want to find the sine of 60 degrees. Remember that I could make my unit circle. Go ahead and draw my 60 degree angle there. That wasn't a very neat drawing. I might start over with that. So maybe I'll just draw the triangle because I know that it's in the first quadrant. So here's my 60 degrees. So across from the 60 is radical 3 over 2. Across from the 30 is 1/2. Hypotenuse would be 1. So I need this ordered pair on my unit circle. That ordered pair would be 1/2 radical 3 over 2. And since it's the y-coordinate, I'm going to take the y answer and say that this answer is equal to radical 3 over 2. This one was 1. Let's go to part C. So first of all, let's convert 3 pi over 2 over 2 degrees. So multiply by 180 over pi radians. Pi's are cross-canceling. 2 goes into 180 90 times. 3 times 90 tells me that I really want the cosine of 270 degrees. Now this once again is a quadrantal angle. So draw your unit circle, and at 270 degrees I need that ordered pair, 0, -1. Because I'm doing cosine, it's equal to the x-coordinate at that point, so the x-coordinate is equal to 0. And let's finish the last one, cosine of 3 pi over 4. Step number 1, convert 3 pi over 4 over to degrees. Multiply by 180 over pi. Cancel the pi's. And this is telling me that I have an angle of 135 degrees. So I want the cosine of 135. I recognize that as having a reference angle of 45. So if the reference angle is equal to 45, this is going to be in quadrant number 2, so I'm going to have the negative answer for the cosine of 45. That's just going to be negative radical 2 over 2. I could have also drawn it on my unit circle. So you see the process for evaluating trig functions. These were all given to me in radians, so I had to take the first step of converting them to degrees first, identifying what quadrant they were in, finding the reference angle, if it's not a quadrantal angle, and then making the right triangle so that I can find the value. And again, you'll notice that in B and in D I ended up with irrational answers, so a decimal answer would not be acceptable there. We'll keep practicing with our sines and cosines, and our next lesson is going to include graphing sines and cosines. But in class, we'll do some practice with evaluating sine and cosine given reference angles and quadrants. Have a great night, and we'll see you next time. Bye-bye.